Hi everyone, welcome to that second part of the AC circuits fundamentals. In previous class, we discussed regarding reactance of the circuit, impedance of the circuit, and expression for reactive circuits and their impedances, and differences between AC and DC voltages currents like that we discussed in last class. Now this is the another class. I want to concentrate on this particular class about various powers in AC circuits. Now coming to that outlines of this class, now I want to concentrate on active power, that is represented as capital P. Reactive power, it's represented by Q. Apparent power, S. Power factor, it's simply called PF. And power triangle and modal problems on these particular various powers in AC circuits. Now coming to that various powers and their definitions. Now active power. Active power is represented by capital P. The active power is actually performs that useful work in the network. So this power is a responsible power to do some useful power work in the circuit. The unit for this particular power is watts. Watts is simply represented as capital W. Coming to that reactive part, that is Q power, this power produces the required magnetic property in the circuit, which develops or produce the required flux in the circuit. To do the active work, the reactive power is very important in the circuit. So that particular reactive power is defined as represented as Q, and unit for this reactive power is nothing but, so it's represented as var, var. So the unit for reactive power is var, and third power is nothing but apparent power, is represented by capital S. This is the vectorial sum of the active power and reactive power. The unit for active power and reactive power, apparent power is volt amperes. Volt amperes. Now, I want to give that various powers in DC circuits and AC circuits. So already we know that in the DC parts, these are that various expressions for power. Power is equal to voltage into current. Power is equal to I square into R. Power is equal to V square by R. These are that various powers expressions for DC circuits. Now we are working on AC circuits. AC circuits. So that the power for AC circuit, the active power is defined as voltage into current. This is the same, voltage into current, same, but additionally we are taking, this is the cos theta. Cos theta is the additional content in the reason. Why? Because in DC, theta value is equal to 0. Whereas coming to that AC, the phase angle between voltage and current is theta is there. So that we have to consider the theta. Cosine angle of the theta is nothing but power factor. So AC power is defined as voltage into current into cos phi. Similarly, the reactive power Q is defined as VI into sin phi. And apparent power is defined as, that is nothing but simply voltage into current. So now once again I am finalizing the power expression for AC circuits. The active power or real power, that is a capital P, is represented as voltage into current into cos theta. Reactive power Q is given as voltage into current into sin theta, and apparent power capital S is given as product of voltage into currents. So in that way we have to write that various expressions for various powers. And similarly, now I want to give that the relation between active power, reactive power Q, and apparent power. So already we know that the apparent power is the vectorial representation, means this value is equal to, so this is that value, so the S is equal to sum of capital P plus JQ, where P is equal to active power or true power, Q is equal to reactive power, it is imaginary parts. So that the magnitude of capital S is equal to square root of P square plus Q square. And P is equal to magnitude of S into cos theta. Magnitude of S is equal to voltage into currents. So P is equal to magnitude of voltage into current into cos theta, and Q is equal to magnitude of voltage into current into sin theta. So coming to this particular power triangle, see here in x-axis we are representing active power or real power. This is a real power is a reference axis. In the y-axis we are taking, this is that reactive parts, means imaginary part, the power which creating that magnetizing property in the circuit. And vectorial summation of the active and reactive power is nothing but apparent power. Apparent power. In that way, we have to give that relation between power, reactive power, and apparent power. Now, I want to explain what is the concept of the active, reactive, and S power. S power. So now, this is the case. This is the case. So already we know that this is that the case is nothing but here. So this is that power triangle. Power triangle. So let us consider this is the whole glass. So this is the glass. Now, if you are interested to take that soft drink, let us consider Sprite or Thumbs Up, Coca-Cola products, like that. This particular part, this is the black color part is nothing but active content, active liquid. And this is the white color content is nothing but reactive part. It is a foam. It is not active element. It is a gas. It is a acid. But we have to understand that without this particular foam, there is no value for this active parts, liquid. So therefore, to make the sense for active content, we have to add the reactive parts. Means to activate the operation of any element, the reactive power is required. The sum of this Q and this active power is nothing but apparent power. Is nothing but apparent power. In that way, we have to make the sense and importance of the reactive power in the circuit. Suppose now let us consider your motherboard of the computer. If that computer is working properly, means the required AC elements, AC circuit elements working properly, means the AC circuit, means reactive elements of the circuit are producing the required amount of the reactive power in the system, so that your system is rotating and you are doing useful work. In that way, that particular active part, active energy is consumed by the element, and Q is nothing but giving the support for that to do that useful work in the system. So these are the relation between various powers, that is active power, reactive power, and apparent power. Now, next part, we have to go for this one, power factor. Very, very important. The power factor is very important here. The power factor is defined as, it's represented as PF. It is a ratio between, so it is a ratio between true power and apparent power. So in the other terms also we can define that the power factor is equal to cos, power factor is also defined as cos theta. Cos theta is nothing but cosine of the angle between voltage and current is known as the cos theta. That cos theta is nothing but power factor, is defined as power factor. So here two expressions are there. Those are nothing but power factor is defined as the ratio between active power and reactive power, and power factor is also defined as it is a cosine of the angle between voltage and current. So this is the power factor. Here power factor is playing very important role. Power factor is playing very important role. So already we know that in DC, power is equal to voltage into current. Voltage into current. In AC, power is equal to voltage into current into cos theta. Cos theta. If cos theta is unity, the power is very high. If the cos theta is decreasing, the power value is decreasing. So always we are hearing one thing is nothing but if we are not maintaining power factor as unity value or desired value, we have to pay the penalty for electrical power systems, electrical power companies. Even in our college also, we are maintaining some power factors. So power factors always we are maintaining power factor. It is better to maintain one. At least we have to maintain the power factor. So 0.9 at least in better case. If the power factor value reduces, the total active power also reduces. So in that way we have to discuss regarding that power factor, and power factor is a very important one. So the ratio between that power factor, power factor definition is the ratio between real power and apparent power. The other definition is the power factor is also defined as the cosine of the angle between voltage and current is also known as power factor. Simply power factor is equal to cos theta. Cos theta. Now I want to give that small example for that total discussion. So total discussion is nothing but, so now I want to calculate the various quantities from this problem. Calculate the following for the given circuit. Means thus value is equal to the circuit consists 20 ohms and reactance 10 Henry, and that circuit is supplied with sinusoidal voltage. That sinusoidal voltage is equal to 100 sin 10t. 100 sin 10t is nothing but that is a supply voltage. Now we have to find various values here. A bit XL means reactance. B bit impedance, Z value. Already we know that Z is equal to R plus X JXL. Total current, voltage across 20 ohms. Power factor is nothing but cos theta. Here we have to find the theta and apply the cos value. And active power is nothing but VI cos theta. Reactive power, VI sin theta. Apparent power, VI. Like that we have to apply all these content and have to calculate the required forms. Now coming to that solution part, so given that R is equal to 10 ohms and L is equal to 10 Henry, and Vs is given as supply voltage 10 into 100 into sin 10t. Here 100 is nothing but Vm value, peak value. So peak value, so that omega t is equal to 10 radians per second. Omega t is nothing but 10 radians per second. Here sin omega t. So in omega, so the value is there, that is nothing but 10. So that we have to take omega as 10 radians per second. Now coming to that first bit, reactance. Already we know that XL is equal to omega L. Omega is equal to 10 and L is equal to 10. So that value is equal to 100 ohms. The unit for reactance is equal to ohms. The unit for impedance is also ohms. The unit for capacitive reactance is also ohms. So that I am taking that unit is ohm. Now second bit is we have to calculate impedance Z. Z is equal to, already we know that Z is equal to this value, R plus JXL. That is nothing but 20 plus J100. So this is nothing but, so here the magnitude of Z is equal to square root of r square plus xl square. So substitute those values, we'll get 101.98 ohms, 98 ohms. So now coming to that C bit, total current. Total current is I is equal to V by Z. I is equal to V by Z. So V is equal to 100 and Z previously we calculated from second bit. It is nothing but 101.98 and 0.98 amperes. Here I am taking, this is the Vm value. So here I am taking Vm so that the current is also peak value. Voltage across 20 ohms. Voltage across 20 ohms is equal to, so this is V into, so VR is equal to I into R. Already calculated current is 0.9 ohm and resistor is given value 20, so that voltage is equal to 19.6 volts. Now, it is very important to calculate that power factor. Power factor is nothing but cos theta. But here we have to calculate what is the theta value. Theta value is nothing but Z is equal to Z is equal to 20 plus J 100. So theta is nothing but tan inverse of imaginary part by real parts. So in imaginary part is equal to 100, real part is equal to 20. So that we are getting, so theta is equal to 78.69. Therefore, power factor is equal to cosine angle of the angle between voltage and current. So that we are getting 0.196. That is the power factor. In the next case, that is F bit, we have to calculate active power. Active power, active power is calculated as, so this is nothing but, we know that active power is equal to VI cos theta. So VI cos theta, VI cos theta. So VI cos theta means, so V is there. V is nothing but, here Vm by 2. Previously I calculated peak voltage. Always we have to convert those peak values into RMS values, so that I'm taking by root 2. Why? I'll give that in the next class. So similarly, RMS current I am taking and cos theta. Already all these are the known values. So voltage value is given, current value we calculated from the third bit, and cos theta, theta value also calculated in the previous bit. So finally, the active power is equal to 9.60 watts. The unit for this one is equal to watt. Similarly, I am calculating reactive power. Reactive power is nothing but VI sin theta. Vi sin theta means this value is equal to V. This is the RMS value. Sin theta. All these values are calculated. Finally, we are taking the product and theta value or sine of theta value, so that we are getting 48.069. See here, the active power is less. Here the reactive power is less. Already we know that what is the importance of the reactive power from our previous analysis. So always it is better to maintain active power is more compared to reactive power. Similarly, next we have to calculate apparent power, that is S. S is nothing but VI. All these are RMS values. So RMS value is equal to Vm by root 2 means 100 by root 2. Current value, peak value 0.98 by root 2. So we are finally getting 49 volt amperes. In that way, we have to calculate various values from the given circuit. First we have to calculate impedance, then we have to calculate power, current, power factor, theta value, and all these things we have to calculate from the given. So why I am taking this question is nothing but, instead of calculating, taking various number of questions for calculating each and every component for single by taking so many problems. So this is the simple problem I consider and inserted all the quantities to calculate from that problem. So in that way we have to calculate, make the sense for various powers for that particular problem. Now coming to that assessment, before assessment part, I want to highlight what are the discussing point in this class. So in this class, we discuss regarding active power. Active power is nothing but the power which will convert that useful work. The reactive power means this is the power which produces the required flux in the circuit. And apparent power is nothing but it's a factorial sum of the real power and reactive power. And next part, we gave that relation between all powers. That is apparent power is equal to P plus JQ. So S is equal to square root of P square plus Q square. And all these are that very very important definitions, and all these powers and their units will occur in online examinations also, multiple choice questions. So like that, here I am giving some assessment. What is the standard value of frequency for AC currents for Indian systems? Always it's a 50 hertz. For foreign countries, it is not for all foreign countries. For other countries, it is a 60 hertz. But for Indian all industries and equipments are using or designed at 50 hertz only. Coming to that second part, PF is nothing but power factor is defined as the ratio of active power and reactive power. So power factor is the ratio of real power and apparent power. Now coming to that third one, what is the unit of inductance? Reactance. Reactance is also similar to ohms, impedance, ohms. What is the unit of reactive power? Reactive power is Q. Q unit is nothing but var. What is the unit for active power? Active power watts. What is unit for apparent power? Capital S. Capital S is nothing but VA, volt ampere. And similarly, previous is the bit. It's a very important bit. If F is the frequency of sinusoidal voltage, then its time period is equal to F is equal to 1 by F. T is equal to 1 by F. So like that, uh, we have to answer that online bits whenever the exams will go. Next, coming to that, this is the feedback form. I think we reached the almost all fundamental concepts in this class: powers, various powers, and relation between them. And next thing, I want to concentrate on. Next part, I want to concentrate on. Previously, when we are calculating active power, we make some sense Vm by root 2, that is RMS value, Im by root 2. Why we have to take that root 2? I'll give that concept clearly in the next class. So please make the sense and try to learn what is the importance of active, reactive power and apparent power and relation between them in this class. Thank you one and all. Thank you. It's okay.